Hi everyone, thanks for joining us for today's webinar, Introduction to Storm and Sanitary Analysis. Our presenter today is Tom Moen from CTC. Before I send it over to Tom, I want to remind you, you are all on mute, and if you have any questions, please put them in the question queue and we will get to them at the end of the presentation. We are also recording this presentation. The video will be posted to our YouTube page in the next couple of days. So without further ado, I'll hand it over to Tom.
Okay, thanks, Ben. Hello, everybody. As Ben said, we're going to be doing an introduction to storm and sanitary analysis today. My name is Tom Moen. I'm an EIT and application engineer with CAD Technology Center. I've been here a handful of months, so fairly new to CAD Technology Center. Prior to being here, I did work with Bolton and Mank, did some stuff with agricultural drainage and municipal work. So let's get started with things here. Just a fair warning, I'm going to try to get this all fit into the next half hour. We may go a couple minutes over, but I'll do what I can to keep things moving along for us. And any questions you do put in the chat window will be archived, and I'll be able to address those and get answers out following the presentation. Okay, so Intro to Storm and Sanitary Analysis, SSA. Hopefully what we want to do here is show you guys kind of how to get around in the interface. We'll look at what's on the toolbars, what's on the data tree. We're definitely going to get into how to set up your hydrology to get your runoff, do your routing and hydraulics, and show you a lot of the versatility and the power that's involved in the application with all the methods that you do have available to you. Big part of SSA is, as the title implies, it's analysis. We can do some design modifications. You can do a design from scratch, but there's a lot of ways to look at your analysis, generate reports at any stage or an overall report, both the physical properties and analysis results, and to look at those in several ways that we're going to see here once we get into the application. Sort of the way that we're going to frame this is we're going to do a workflow where we start in Civil 3D, which may be a useful workflow, and show how we can export out our pipe network data and also our catchment data. We're going to show how to make catchments if you're not familiar with that in Civil 3D. Push that out to SSA, where we can run our analysis, fill out some more of the more robust hydrology inputs within SSA, and then export back and push our updates to Civil 3D. So the problem, or why do we want to use SSA? Now, well, as I said, it can be useful to start your preliminary design. You're doing your alignments, you're doing your site work in Civil 3D, you get your pipe network set up, and now we need to do some analysis. And what better way to run the analysis than to use the actual preliminary design, the actual pipe network you've started with, and let's push that out to SSA and come back with any updates to Civil 3D. It can be a very handy workflow that way. And as I was alluding to before, SSA has a very robust input parameter options, so there's several hydrology methods for runoff, there's several routing methods and hydraulic methods for pipe flow and even pressurized flow, as we'll see, as may be dictated per project. So a couple steps just outlining what we're going to get into. We're going to have our basic pipe network set up. I'm going to show you how to make a catchment in Civil 3D, and also with a simple surface made from grading tools to model a little pond we've got. I'm going to show you how to generate a stage storage volume report and how to use that in SSA in the model as a storage node. Then we're going to go into SSA. We'll import that Civil 3D data, the pipe network and catchment data. That's going to fill out all the information along with it in SSA. We'll go in and we'll set some of the hydrology parameters and inputs, and we'll run an analysis. I'll show you where we can generate reports along the way, push those quickly out to Excel, out to different formats you can use in a Word doc or PDF as well. And we're going to use, within the Civil 3D to SSA workflow, we're actually going to use what's called states in SSA to save states of our design process. And I'm going to show you how that works once we get into SSA. There's a little bit of a trick workflow that we're going to use to push updates back to Civil 3D. Okay, so let's get into the application. I'm going to open up my Civil 3D drawing here. I've just got, in the background, I've got an image XREF'd in. Okay, I've got a couple runs of pipe, some catch basins along here, and this is pond surface that we've got we're going to use to generate the stage storage volume. So let's go ahead and make a catchment so that we can use some of the site that we've got built in SSA and push that out with our pipe network, or that we've got built in Civil 3D rather than push that out with our pipe network to SSA. So there's a couple of ways to do this. The first step, either way, is going to be to create a catchment group. And you can build a catchment based on the slopes on your surface in Civil 3D, but that can be kind of buggy and you can end up with some strange shaped slopes. So the recommended workflow that we like to point to is let's just create our catchment boundary with P-lines or polylines, and then also create the flow line or the flow path with the polyline, and we can point to that with the create catchment tool. So I'm just going to make one for this catch basin here. Fairly simple. And let's put in a flow path. Maybe it's running close to the edge here. Just a couple of polylines. And here you can create from surface, create from object is what we're going to use. We're prompted to select the boundary for our catchment and to select the upstream end of the polyline. Okay, so we get our wizard popped up. One important step here is that we want to reference a pipe network and reference a structure. That way the catchment is going to get pulled along with the pipe network out to SSA. So we'll go out, this will send us back into model space here, and I'm going to grab my structure, my inlet, and right now I'll switch over to the flow path. Time of concentration, Civil 3D can use TR55 to do time of concentration or user defined, so you're fairly limited there, but we'll see how we can fill some of that out and then expand on it in SSA. I am going to assign a slope based on the surface I've got laying underneath this flow path that I've drawn. So I'll do from surface, and I've got a composite surface in there. And there we go, it's built out for us. We can grab that, go in and edit flow segments. And right now you can see that for the entire length along that polyline, it's given us shallow concentrated flow. We can add a channel flow and sheet flow if we like. Just hit our little plus and it's asking, okay, where do you want to cut off the next flow segment? Let's go somewhere around 100 for a sheet flow. And you can see that the length's updated for the shallow concentrated flow as well. There's a default 2-year 24-hour rainfall. Maybe that's a little lower. I can always go in and change things. You can also see slope pulled from the surface. I'll give this a roughness of 0.3, and you can see my time of concentration is generated over here. So that's all there is to creating a catchment. I'm going to do a little bit of pre-baked magic here and open up a drawing that's got the catchments built out. And so I've got 2 others in here, and we can always go into catchment properties and see how that's all built. So this has some sheet flow in it, some shallow concentrated flow and channel flow, and it's all a summation of all 3 flow types is listed right here, along with a reminder of the method used for time of concentration. Okay, so let's look at our pond over here that we're going to outlet into. So this is built with grading tools that are grading out to the existing surface from a feature line. And you can see that some of the contours are not exactly perfect. They're not complete contours. And the stage storage tool that we're going to use to get a stage storage volume to be used in SSA needs to have neat and tidy contours. So what we're going to do is actually define a put a user-defined contour in at our outlet, and we're going to add that as a boundary. So what we want to do is go into our surface properties, going to do a user-defined contour analysis, push that down. I happen to know I want that at 961. Okay, and before we leave here, we'll go in and we'll turn on our user contours so we can see it. Okay, so now it's displaying, but we can't grab it separate from our surface to add as a boundary. So to do that, we'll grab and extract from surface, and we'll just pull out our user contour. Okay, and now that just generated a polyline we can use to add as a boundary. So let's go ahead and do that. Got my pond, and I'm going to add an outer boundary, give it a name if I wanted to. I'm going to use that, and there you can see the display of the surface update for us. And the next thing we're going to do is go in and get that stage storage volume brought out. I'll give my composite service a little update here. Always good to keep on top of those. So let's get that stage storage. So analyze down here. And we could fill out a name, project name, and everything if we wanted to, specify how the volume calc is going to run. But the important thing is go out and get our data. So define basin. Again, I could give this a name. And I'm going to use my surface contours to generate this. So one thing to note, you'll see that there's multiple levels of 961 put in there. You know, things aren't always flawless, so we've got some extra rows where our volume's not actually increasing, and we'll see where we want to trim that out once we get into SSA. But for now, that's okay. It is generating our volume. So the next thing, we just want to save that out, and we can see it's getting this file format, and just call that pond. Okay, so that's all out. Now let's export out to SSA. Before we do that, we'll go into settings, and I'm just going to show how things are translated. So you may be familiar with the older software used in conjunction with Civil 3D HydroFlow storm sewers. It's actually going to use the same file type to push things out, and some of the same part matching takes place. So if we actually go into our settings and look at that, edit in storm sewers, and we'll go to storm sewer migration, part matching defaults, we can look at, okay, when we import from storm sewer, if we import a combination inlet circular, we're going to get an eccentric circular Civil 3D object. You can also look at what comes in. So when we push out from Civil 3D, there's a little bit of a limitation on what exactly goes out, how that's read in SSA, but the essentials, a pipe's a pipe, the catch basins and inlet, that sort of thing all works just fine. Okay. So to export, I'm just going to grab a piece of my pipe network. Now you'll see the edit and storm and sanitary analysis button here. Basically this is just an automation of popping open SSA, importing our STM file or what's exported here, and starting a new SPF or a new SSA project file for us. Doesn't always work. It's not working for me right now. I'll just be honest with you guys, but there is another way. It's not that much more difficult. We just export the file manually there, make sure we're grabbing everything we want. Okay, and let's call this C3D to SSA. Okay. Now when you're working with stuff exported from your drawing in SSA, sometimes it doesn't like you to have the drawing open. So I'm just going to give this a little save, and let's close the drawing out, and we can come back to it. I'm going to close this guy out too. Don't need to save him. Okay, let's switch over. Now we are in SSA. Okay, so the first thing we're going to do, I'll just point you to some of the stuff. We're not going to have time to go through each and every little tool here, but your toolbars are up top. This is where things you use most often are. You can go into display options here and reset how things look when they come in. There's some nice tools for querying objects. The main things you want to be aware of are right along this toolbar. These are all the tools we're going to use to build out things. So this is your sub-basin. I'm just digitizing. Maybe I've got an inlet, an outlet, junction, and a node. And I'm just going and building things in here. Let's connect this to our inlet. So by default, things are set. It's a circular pipe. Maybe we wanted it to be a culvert. Maybe it's an open channel. One thing to be aware of is SSA is kind of in between schematic and drafting. So you can see that a length was assigned here to this link. If I wanted to grab that and move it, it's not going to automatically update, even if I close out 819. Okay, but what we could do is we can come out here. If I actually wanted that to have the length represent where it is on the screen, where it was moved to, go in and recompute length, look at it, and you saw that update there. So fairly simple. You can build a model from scratch, but let's go in and let's import what we got from Civil 3D. I'm just grabbing multiple parts here, and we'll clean our stuff out. So I'm going to open up a project that I had started earlier. All I did was I got some of the hydrology set up. I'll show you what we did here. For every project, you're going to want to go into project options, analysis, and either an IDF curve or a rain gauge to assign everything you're going to need to run your analysis. So we'll go into project options. You can go metric if you want. You can reset all the units you're using, depth and elevation. Here's the cool stuff about SSA, hydrology, how we're getting our runoff. So I'm going to use TR20 for this example, but these are all the different methods you can use, and depending on if you're using EPA SWIM, it's going to ask you for different inputs as you go along. There's the old rational method if that's what you'd like to use. We've got TR20 available. Let's use that. I'm going to do a time of concentration from TR55. You saw all of the multiple options for running your hydrology. So that's one of the big power pieces of SSA is its versatility there. Let's give it a minimum time of concentration so we don't go too short. Okay, our routing. We can have steady flow between nodes. We can do kinematic wave to get our continuity and momentum accounted for. Or we can go hydrodynamic, which is basically the next level of complexity and accuracy. This can account for reversed flow. You can get pressurized flow if you've got a manhole lid tied down and you're filled up. It's going to be your most robust routing method, and if we've got that available to us, let's use it. And then when things do become pressurized, or if and when they do, we can use Hayes and Williams or Darcy-Weisbach here. Okay, you can also go in and reset how the naming templates for things that come in. A lot of properties you can get messed with, but the big thing is you want to make sure your hydrology and your routing stuff is set up. Okay. Next thing is go into your analysis options. There's a lot of fun tools in here. We're not going to be able to get into the extent of everything you can do within here, but the important piece is you need to run your analysis for a certain amount of time. The default is that there's no time set up here. So this would be, set to 10-2. I'm going to run this for 2 days. I could do this by setting a number of hours if I wanted to. If I wanted to do 3 days, we'll leave it on 2 there. If you are seeing some funny things happening with your routing, you may want to give a lengthening time step so things have time to fully route along your pipe runs. So maybe if needed, I give it a longer time step, lengthening time step, and this is for hydrodynamic. And maybe I want, let's do a 5-second time step to have things a little bit more accurate and just calculated for a more tight time step. Okay, your storm selection. This is where you're going to input, okay, what kind of frequency event, what am I going to look for? Okay, before we do that, we define those events over in rain gauges. Okay, so what I've done, when you start a new project, this is all kind of going to be blank, okay, and you're going to want to add a new one, and then we're going to hit the ellipses here, go out and define our time series. You're going to add a new one. So if I wanted to add, let's just say I wanted to add maybe a 1 year, go to your rainfall designer. Which intensity curve are you working with? Okay, so many options in here depending on where you're working and what your situation is. I'm going to stick with a type 2 24-hour SES. You can do an intensity or cumulative. And then this is all pre-built in SSA. So what state am I working in? Well, this one's in Minnesota County. We're in Stearns County. And I think I said I want a 1 year event. Okay, that's 2.2 24 hours rainfall. Okay. So now I've got that 1 year built in there as well that I can choose from, and I could go and add these in. I could save this out if I wanted to, okay, because you can go in here and you can edit things. You can insert a row for a new time, and you can define your own custom curve and save that out if you wanted to. Okay, and you can bring those in that you've saved out maybe from another project. Okay, so that's my rain gauge is defined, and let's say let's go with a 10 year right now. Okay, so we've got that all set up. Now let's bring in our Civil 3D data. So I'm going to go to import hydroflow storm sewers. Right there it is. You want to update the project? Yes, I do. And it's just going to give us a little log file of, what we did, what we brought in, etc. We'll switch over back up to your toolbars for a second. We've got a couple of tools for zooming and panning and moving around. This is the one that I like to use. You might be familiar in Civil 3D. You can do the double-click middle mouse wheel and it'll zoom extents. Not so in SSA. You want to hit your zoom extents right up here. While we're looking up on the toolbar, this is also where we're going to generate our reports. These are overall reports. So we've got the PDF and Excel here for your entire project, and you can come in and set how you want those reports to come in, what formats are available, what is to be included, and there's a lot of stuff you can set up for how you want your report to look. Okay, and move down the line, and outflows, weirs, so on and so forth, and you can set everything for how that's going to be populated there. Okay, so we've got our Civil 3D data brought in. One other thing we can do is we can import a background, and this is what's done through a layer manager, and we can actually just bring in the drawing itself. Now this isn't actually going to bring in a C3D drawing. It's going to use it as like an image background basically. But if you did have that drawing open in Civil 3D, it might bark at you a little bit and say, hey, what are you doing? But it can be good for reference, especially if you're digitizing and moving things around. Okay, first thing I'm going to do, so I mentioned earlier that we're going to use SSA states to save things. So what I'm going to do here, before I get into setting up my analysis, I'm going to go up, and this may be a little bit confusing as to why I'm doing this at this point, but when you do this Civil 3D to SSA and back workflow in the future, you're going to see why. You're going to see want the workaround and come back to the video, check it out, and you'll be able to do this part. So let's just call this import. So this is right after I imported. So what this is doing, it's going to save the state of this project as it is without having to save a brand new file right here. So import, okay. And now let's go ahead and do our modifications. I'm going to grab my sub-basin. So this is a sub-basin. It doesn't actually have the hatching that you saw when I used the sub-basin tool up here, but it was brought in from Civil 3D catchments, and it is a sub-basin. I'm just going to put it kind of where it lives. So when you import from C3D, your inlet structure is going to have an off-site outfall right away. So anything that comes up to the top of the rim of your structure is just sent off-site. That's not necessarily accurate or what I want. So I'm going to go ahead and get rid of those outlets right away. Okay, get rid of that one as well. This is every SSA network does need an outlet, so this one I'm leaving in. Okay, but what I am going to do is I'm going to right click, and you can do this with any type of node, right click on it, and I'm going to convert this to something else. And I'm going to use my storage node. This is what I'm going to use to model my pond. Okay, but now like I just said, I do need an outfall. So let's put an outfall back in, and we need to link those together. So let's link them up. Okay, I know that the bottom of my pond is at 950. Okay, so I'm just going to set that invert elevation of my outfall. We'll go into my pond, or my storage node. Like I said, I know the bottom of it is at 950, and let's just say the top is 965. Here we can use a constant area and a multiplier for a functional type storage. I'm going to do a storage curve and use that data I pushed out from Civil 3D. So we can go out and we can load our pond. Okay. Now I mentioned that this can bring in some extra rows. If we were to run the analysis, this is going to say, hey, I want to increase at every row. Okay, so all these extraneous rows, I'm just going to right click on it, do a shift select there, and once they stop increasing, I'm just going to get rid of those. Okay, so now we're all set up and we've got our storage curve for that pond. We could do some exfiltration if we wanted to. One of the nice things in SSA is we've got our handy dandy charts just built right in. Let's just say maybe I've got sandy clay loam. Okay, so we got some exfiltration going out of the pond too. Okay, this should be all set up. Next thing, I added that link in here. Okay, and this isn't actually a pipe. Okay, this is just saying that after you're in the pond, that's the end of the model. You're leaving the site. So we can do that with a direct link. And before I do that, I'm actually going to set the invert and inlet and outlet elevations. And I'll set that back to a direct link. Okay. So at this point, we're going to go into our inlets. One of the things I'm going to point to is that we can have this on grade or on sag. If you've got it on grade, you need to have a bypass link set up. And so what that can do is that can, okay, if things come up over my inlet, I'm going to have a bypass link set down to my next inlet. And I was hoping to set some of these up for you. We're getting a little tight on time, so what I'm going to do is actually set this to on sag, and then this is going to allow ponding on top of the inlet, and then once there's more capacity, it's going to run back through. So I can go through and let's just set this to on sag, and make sure we got them all set. Okay. Set that to on sag to allow ponding. On sag. Okay. So at this point we should be ready to run our analysis. So that's our little running man right up here. And what this is telling me is that I didn't assign a rain gauge. So it's pretty, when you get these errors, it's pretty nice. It's fairly intuitive a lot of the time. So let's assign our rain gauge. Let's go in here and assign to all subbasins. Here we go, it's running our analysis. I could save this out if I wanted to, just save the state of the analysis. Okay, and let's look at our profile plot. It's going to ask me for a path of what I want to look at. Let's just go along here, show the plot. And this, there. Just push a little update to that pipe. Okay, so right now what this is showing is that at this time step, this is the maximum hydraulic grade line, and this is the maximum water level achieved over the entire run, the entire analysis. What you're probably going to want to use here is to go to your output animation, and we can actually watch this in real time over the storm event. And I'm just going to bump up the speed. Let's move this up to somewhere where it gets a little interesting. We can see some flows start happening, and there we can watch our storm event and what that actually looks like. Okay, we've also got profile plot, our time series plot. So we could go through and maybe look at what's our rainfall look like, what's our runoff, and at any time here we can go in and right click, we could export to Excel or Word any of these little pieces, or as I said before, your overall report for your whole model is right up top here. You can export time series plot. You could put it right in your drawing in CAD if you wanted it on your plan set. You can go to Enhanced Meta File to push it out to other programs like Word. Okay, so let's go back. Now, let's say that, well, I didn't really need these 24s because we had plenty of capacity. I'm going to push those down to 18s. Okay, let's run my analysis one more time. Okay. And now it's kind of barking at me saying that we're surcharged here. Okay, so let's just take a look at what it actually looks like in our profile plot. And we'll do our output animation. And we got a little bit of surcharging up over the pipe there, not that big of a deal. Okay, so what the changes I made was I bumped these 24s down to 18s. Now here's where our workflow for going back to Civil 3D is important. I had to add this direct flow link, and if I were to push that back to Civil 3D, what it's going to do is it's going to say, hey, you got an extra pipe in here. It's going to read it as a pipe. It's going to create a new network. Not all bad, but maybe I don't want to be creating new networks each time. So the workaround there is to say, okay, I changed these two pipe sizes. Let's go back up, and I'm going to make a new state. Call this maybe analysis. Okay, go up, track change options, and I'm going to go back to that import state and restore that. Okay, if I wanted to go back to my analysis, I could always restore that again. I'm going to get rid of my extra little outfalls here and just make those changes that I know I made based on my analysis. Okay, just changed a couple of sizes. Okay, now I'm ready to go back to Civil 3D, export storm sewers file, and we'll just give this a little number tag. Okay, successfully exported. Do you want the log file? No thanks. We're done in SSA for now. Let's go back and open up our drawing in Civil 3D. You can see here these are 24s, and let's import that back in from our updated STM file. Do you want to update the pipe network? Yes, that's what I was doing. And it's just saying that one of the structures was not matched exactly going SSA to Civil 3D. But you can see that those updates were pushed back, and now we have two 18s. So with that little simple workaround from SSA to Civil 3D, you can go out, run your analysis, and push things right back into Civil 3D. Okay. Alright, so sorry for running a little bit overtime, guys, but we'll wrap this up here shortly. What did we learn? Looked at the round trip from Civil 3D to SSA. You do your prelim stuff in Civil 3D, set up your pipe network, get that started. Okay, is this going to work? Let's look at my runoff, do your analysis, and with that workaround I showed you, you can do modification in SSA and then push back to Civil 3D with that STM file export. We saw that hopefully I was able to portray in SSA a lot of the versatility. We looked at all the different hydrology and hydraulic methods you can use. Some of the ways that you can push reports out and view your analysis in plan view in that real-time profile plot and time series plot. I also did a little bit of just starting a from scratch design. You can do that in SSA too as well if you don't want to start in Civil 3D, or if you've got some other preliminary stage of analysis you're running.